I absolutely love that you guys have our cell phone numbers, right? Like, that's really beneficial to our program. It streamlines things. But when I get a text at like 8 o'clock at night saying, what's the homework? I'm confused on what questions to do. There should be no confusion. When we're in Chapter 4, the homework's going to come from Chapter 4. If it's problem 41, it's going to be 4-41, right? So that's why you want to have 4.2.2. So when you're in the textbook or when you go online, guys, don't carry your textbook home if you have a computer at home. Go online, access the digital textbook, and just go to 4.2.2. Scroll down to Review Preview, right below the math box. It's gonna be your homework, right? Review Preview is pretty much always your homework. I sometimes take a couple of the questions out. As we get deeper in the year, I'll do more of that. But don't make your life harder than it needs to be. You don't need to take your textbook home. You don't need to... Now, one thing I will say that I've talked to a couple people about, you do need to take your toolkit home. If you are taking homework home, if you are doing homework at home, your toolkit should go home because that's where we take all your notes and all of the math notes boxes. I've had a couple people ask for help on things that are in the math notes boxes. So please take a moment to remind yourself that in the toolkit there is more than just what you do. There's all kinds of like, hey, here's how you solve these problems. Your toolkit's really important. This is like if I were to show up to a job site to work on a project, back when I did landscaping or like when people hired me for random stuff, with no tools. Right? That'd be ridiculous. I'm like, oh yeah, I'm going to cut the tile by hand. What? I'm going to stare at the board and hope that it cuts itself. Like, no, you need your tools. That's why they called this a toolkit. You literally need your tools to complete that project. Your project is your practice. Your tools are your math knowledge. Any questions about toolkit, plan book, math journal, any of that good stuff?
What's the date today?
25th. Today is a very average day, and you're gonna. This is a very bad joke. Are you ready for a very bad joke?
Yes.
Okay, today I say is a very average day.
Oh, average. We're gonna work on average.
If you average the month and day, you get 17.5. So yesterday would have actually been really good because 10 plus 24 is 34.
Divided by 2 equals 7.
So that would have worked out perfect, but I forgot, so bad on me. But yesterday would have been a perfect average day. Today, we're half average, or half off average.
We're on average.
It's what?
That's strange.
That's strange, it is.
We're on average.
So, all right. We yesterday talked about proportional relationships, right? We talked about how Gustavo had his bank account. So pull out that resource packet that you have for this chapter. Pull out the resource packet. We're going to be on the back of the page that we were on yesterday. The back of the page we were on yesterday. What? Why did you steal that off?
I didn't. It was just sitting there. Sorry. No, it's Wednesday.
You can steal 8 if you want. Just make sure you replace it with that little prize. All right.
Yeah.
Now, who can remind us how we can identify when we look at a graph if it's proportional? You should have this written in your toolkit from yesterday's notes. Rachel, what do you got for me? Hey, I also don't know who did this, whether it was the group last class or what. These should not be squared up. These should be turned. They must have, the group must have done this. So if you guys feel like you're awkwardly backwards, turn the group in, if you would. But sorry, Rachel.
Okay.
Proportional relationships. Hit us with it.
It has to be a straight line.
Straight line.
So it has a constant slope.
Constant slope, yep.
And it has to go through the origin.
Through the origin. Straight line through the origin. Gustavo's bank account. Was it proportional? No. But it was linear. Right? So that's what we talked about yesterday. A proportional relationship is linear not every linear will be proportional. We need that origin point. So, we also talked about a penny tower, right? Back in chapter 1, I believe, a long time ago. If we had 0 pennies, how tall would our tower be? 0 tall. When we have 1 or 4 or 15 or 3 or 12, this is kind of ugly. That table doesn't really go in order. But I do see one thing that's beneficial. Right? And if we remember our penny problem, this might be slightly easier. So with your team, go ahead and, well, each of you will obviously copy this, but copy this table really quick and see if you can figure out a way to fill in the entire rest of the table. You can go ahead and make 0, 0 your first row if you want. We know that it says to add it in your table later, but since we already know it, you can just put it in there if you want. I'm going to cheat to plot my points. Sorry, guys.
Can I put them in different orders than how they are on the...
If you want, yeah. You can make your table whatever order you want. So I flipped how my table looks because if we want to talk independent variable, dependent variable, height will depend on pennies, right? Pennies doesn't depend on height. Height depends on pennies. So I made my pennies my x and my height my y. So I flipped these around. Now they had us fill in our 0, 0 point. And if I have these points plotted, I'm going to notice something. Is it going to plot my points for me? What is that? Oh, why can't it plot my points? I don't have anything filled in. I have individual y values or individual x values. I only have 1 point filled in. And 0, 0. Ooh, wait, I have 2 points filled in. So I could, I guess, draw a line and connect these two, and that would be a straight line through the origin. Well, let's see, okay, so if the height of the tower was 1 centimeter, and we remember that probably from chapter 1, if that ingrained in your brain, it took us 7 pennies to get to 1 centimeter, which means 15 centimeters, 105, 63, 9, 21 pennies, 84 pennies. So now what do we
It is
notice?
not proportional. Dots. It is not. It's dots. It's missing values. If we added 1, 2, 3, 4, 5, 6, 7, 8, 9.
Okay, so wait. So we said it took 7 pennies to make 1 centimeter, right? So 14 to make 2.
And then
5, we have 3, 4.
we already have 3.
Okay.
We already have 3.
Okay, that's fine.
So 5, 35.
35.
What do we notice that I keep adding points? It's a straight line.
It is.
Now, here's the only problem with Desmos. It would take me a minute to change my settings to adjust the scale of my axes. But the reason this doesn't look quite right is the scale of my axes is so even. If I make my Y scale a bit bigger, like each box being a different scale, this will stretch up and it'll be easier to see the straight line. This is hard to see that it's a straight line because they're so close together. So what you should really ask yourself, though, is there a direct relationship? Proportional relationship is also called direct relationship. Is there a direct relationship between how many pennies I stack and the height that I get? Well, yeah, because every penny I add, the height goes up. Add a penny, height goes up. Take a penny away, height goes down. Direct relationship. 0 pennies, 0 height. We can solve that it's proportional without graphing it. We don't really have to. But if I wanted to write an equation for this, what could we say? We know 2 things we're working with, height and pennies. Piper, what do you think?
X, which would be the total height.
Then let's just go ahead and say H. I'll use other variables. Height,
I mean, that's why, X or H in your case, equals the H times the, but this is where it gets confusing because you do H times,
so the height is 7 times the number of pennies.
sorry, I got this backwards.
Ah,
What
it's
I was trying to say is it not equals. I was trying to say times 7 equals that, and then I got messed up. Sorry,
Okay.
apologies.
so if we
I
flip
said it
this
backwards. I
around,
flipped it around.
pennies is 7 times height. Now here's what you could have done. If you wanted to do height equals, the height is always a 7th of your pennies. Right? So whether we say pennies is 7 times the height, or height is a 7th of the amount of pennies, 7 pennies equals 1 centimeter. So we have a 7th relationship there. This also shows me that it's proportional because there's a multiplier and nothing added or subtracted. Now, if it said you start with a quarter on the bottom of your stack, that would add on some kind of height. That would not work out proportionally, but this does. Let's look at 35. I love a nice block of pepper jack, right? So Casey also loves cheese. Buys it whenever she can. We got some Gouda cheese there. I heard it's the best. That's why they named it Gouda. So recently she bought 5 pounds of cheese for $15. 3 pounds of cheese for $7.50.
Mozzarella.
So grab your resource page and check out what you think about her purchases. Chez.
I love cheese.
Havarti is a type of cheese. Well, what do you mean, why does it say Havarti? I was talking with her before you interrupted our conversation. That's why I was trying to ignore you. You're so weird. So what do you mean, why does it say?
You're in the way.
If you have a book, oh, I gave you a book that was my gift to you. Yes, well. It's the way. It's the way.
Yeah. Wait, no, that's 5 pounds.
Close to 7. decimals in the wrong place by 1 spot. Yeah, but if we're trying, then you're using a different unit. Do you realize what I mean? If that was in centimeters, how can 1 penny be over a centimeter when it takes us 7 to get 1 centimeter? So I think that might be millimeters. I think you changed units. Graph this. I gave you a nice graph to put it on. Graph it. Make sure we're carefully reading. There's 2 types of cheese. I mean, your resource page should direct you through this. There's 2 kinds of cheese. Yeah, there's Mozz and there's Havarti. So she got 5 pounds of mozzarella for 15. She got 3 pounds of Havarti for $7.50. I'm not going to spoon feed you guys everything this year. You are not babies. You know how to process information on your own. When there's a word problem, you need to read it carefully.
There we go. It runs out at 6. Yeah, but it runs out at 6.
Because you don't have to be in order when you're plotting points. And I have an intention for why I did that. You'll see in a minute. I love that you are willing to ask the question. You keep me on my path, right? Yesterday I started tutoring all my kids, and we were in the wrong textbook. Because I was not doing it yesterday. Yeah, like everyone's in a different textbook depending on which level you're at. So cheese, if you buy nothing, how much are you gonna pay? 0. At least I sure hope so. And although some things in America have unit bulk prices, when you go up to the deli counter, you normally can't be like, hey man, hook me up with a lot of it and discount my price. It doesn't work like that. Deli counters have a price per pound, and that's what you're paying. So I set up this table on purpose, and the one over on the left for mozzarella, when you look at the graph, you might be like, okay, Hudson's lost his mind. But there's a reason why I did this. Who can tell me how, actually, let's just use a card. We haven't used cards yet, right? We talked. Mina, can you tell me how we get 1 pound's price?
Okay, so we know that 5 pounds is $15, so 15 divided by 5 is 3.
So we look at the table relationship, right? We divide by 5 to go down my weight. So we divide by 5, and we get, it'd be 3 pounds. Now, although the graph doesn't do this, once I have a unit price, my life is super easy. You don't have to write these next ones down. But to figure out what then I would pay for 10 pounds, I would just multiply by 10, right? And this would easily become 30. Or to do 20, you multiply by 20 and become 60, or any number from there. Once you have the unit rate, life is super easy. So always compute that unit rate first. We're gonna blow paper everywhere. So 3 pounds, what would that have cost? If it's $3 a pound, 9. 6 pounds, 18. All right, move over to Havarti. Little bit more difficult. Okay, thanks, Ian. 1 is $2.50. How? Sorry about that. That's not a 12. It's my smart board. 2 pounds then. What about 4? 10. Here's the other thing about proportional relationships. If I know what 4 pounds costs and I know what 2 pounds costs, and I'm trying to make 6, I can add them. Very good. What? So 15. But then to get to 5, can't really add things easily. What do you got? 12.5. Or 50 since we're working with money. Please make sure that your table at least have some of those values shown there so that when we go to graph it, yeah, my poster's coming down. We're graphing both. This is where colors are really beneficial. But it says what? I know, we're not going to graph 10 and 20, and those were just so we can look at how easy proportional relationships make finding the other values. So we only have up to 6 pounds, right? So I've got, that's not the right screen. Sorry, 2 screens is a lot to keep track of. There we go. So I'm going to do mozzarella in blue. So I'm going to put up here a little code. Blue is my mozzarella. 1 pound was how much?
1 pound was $3.
$3. I can skip up. I don't need to do every point. What about 3 pounds? $9. And then 6 pounds? Havarti, a single pound was? What about 4 pounds? When we know the relationship is proportional, we really only need to plot 2 points because we already have a third given to us. Right? We know the origin point. And what we want to do, it really only takes 2 points to make a line, but we would prefer to have 3 to make sure our line is straight. So I'm going to do my last point just so I know where I'm going. This would be 1250. From there, right, 6, 12, am I too low? No, that's right. It just looks a little awkward. From there, we'd be able to connect. Sorry, 6 was 15, not 1250. We did 5 last. That's why it looked awkward. So now a straight line. If you can draw a straight line. And it would continue out that way. And straight line. Sorry. I don't have a ruler big enough to do this. And it screws up my smartboard when I try to put a ruler on it.
Oh yeah.
It really messes it up. So now we see they are both proportional relationships. Now we already knew that, but graphing them helps us verify that. Any questions? Straight line, origin point, constant rate of change. That's kind of like a third freebie. Because you can have constant rates of change without being proportional. Now that we're all hungry.
Also lost some cheese. Let's do one about
Where did
burgers.
I drug it to the screen.
Is that a word?
Drug? I dragged it. Yeah, sorry.
I think it's called.
It is dragged. And we already did this, and we already did that. Now, wait a minute. When we look at these graphs, we have continuous lines. All right, I cleared that. So can I only buy 1 pound or 2 pounds or 3 pounds? Or can I buy 3.67 pounds? Could I buy 0.0001 pound? Yeah. What? Yeah, you can have a little tiny bite of cheese. What my proportional relationship also shows me is anytime I want to solve for a value, if I've got the table or I've got the equation, all I need to do, say I want to buy 4.25 pounds of cheese. Go up to where it meets your line. Where it meets your line, go across, and if your line is accurate, which mine is probably not 100% accurate, if your line's accurate, where you meet the y-axis then will be your solution for cost any weight you want. And this is also how the graphing utilities do it for us. Because then you would plug in, hey, graphing utility, if X is 17, I'm having a party, buying lots of cheese. It's not on the table, but the computer can figure out where it would be, and it can spit you out an answer. Make sense? Graphing proportional relationships. Mighty fun. Move on.
But it's still that we need to still continue learning about cheese. More cheese learning.
And this, we already talked about this. That's just going to be our unit rate, right? The 1 pound of cheese we talked yesterday. Anytime you're discussing per one of something, that's your unit rate. So we calculated those to be $3 and $2.50. So this is beneficial. We're going to use this to talk about problem 37. So I want you guys, as your teams, to discuss how can we determine if a table is proportional, how can we use the graph, and decide are A and B, each independently obviously, but are these proportional relationships? So give it a shot. Talk with your team. Now you got to defend. You got to know why or why not. Talking about so. Okay, why are we talking about pi? Have we determined whether A and B are proportional and why? Then stop avoiding what you need to think about by being off task. Guys, as we get deeper in the year, you have to, hey, let me steer your attention for a second. As we get further into the year and we get into more difficult content, you have to fight the urge to avoid not knowing. You have to fight the urge to avoid not knowing. We as humans want to avoid uncomfortableness. We are uncomfortable not knowing. It's dangerous, right? Like our human response to not knowing is that's dangerous. That's exciting in this space. Not knowing in this space should excite you. It should be an opportunity. Do not approach a problem and be like, well, we don't know, let's just talk about nonsense. Like, fight the urge to stray away. Sit there. Sit in that uncomfortableness, that not knowing, and mull it around. Talk it up. Even if you end up not knowing still, at least you spent some time working on it. Exactly. Spending time not knowing is beneficial. is also why your toolkit is graph paper, so you can quickly make a graph if you want to check it. Hey guys, we drew on our desks in Math 7. You do not need to tell me that we drew on our desk in Math 7. It's fine. I announced that at the beginning of the class. It's just not beneficial. We were working with the algebra tiles. It's not beneficial for you to write on your desk right now. I don't care if you write on the desk when it's helpful. Because we needed to make a workspace and a not workspace, and it was easiest to just draw a box. I have plotted those two graphs, or those two tables up here. Blue and red occupy the same space, so sorry I had to make that look awkward. And now my cursor thing won't move. So below, what do you notice as a difference between them? Between the blue points versus the red points? The steepness, right? One of the first things I would notice is steepness. Okay, agreed. What else, May? The red ones are closer together. They make a nice little stair step, don't they? Up one over one, up one over one, up one over one. I like it. Moving dear?
They aren't proportional because they don't.
Both of them?
Yeah.
Okay.
Because they don't go through origin. But they do have straight lines.
Okay, so that's Bouvendir's assertion. Ava?
I think A is proportional because if you just like you know, like with a scale, like adding that you go down, then it would be 0.
Now, I'm going to pull this back down for a second because Ava just said something really powerful. She noticed how we're moving up the scale, up the y's, right? Our y's are going up by how much? Up by 2. Which means if I go the other direction, I would go down by 2. Which means a point where y equals 0, well, how are these changing? By 1s would give us our 0, 0 point. Now, apply the same knowledge over here. Will, what would you like to say?
I was just gonna say that basically in my mind, they can't. How I was thinking is that I knew one was gonna be and one wasn't, just off the numbers that I see like flat out, because there's 2, 4, 6, 8, and then there's 2, 3, 4, 5, and then the same numbers on the left. So the numbers on the right are different. That means the answers are gonna be different. So you can't get. They're either both not proportional. Because in my mind I was like, okay, both are proportional.
Be careful making assumptions about like they are connected in some way.
Yeah, I just
What you said was right, but be careful like looking at them
I just
together.
saw it and I was like, one has to be different.
So if I go back to an x of 0, what would my y be here for red? 1. Now, hold up. Here's the other way. Here's the other thing. If I ask you to look at this table, but say you're not allowed to use addition, subtraction, anything like that, how else could somebody relate my x and my y values? Naya, do you know? You're thinking hard.
Well, I just found a connection in one of the graphs.
Okay.
It's kind of not related to it, but if you do 1 times 4 is 4, 2 times 2 is 4, maybe 2 times 6 times 12, 4 times 3 is 12, 2 times 8.
Where are you from? Wait, 12 what? What?
Here. No, that's mine.
You can always come up here. This isn't like mine. This is your space.
So she's saying that over here, 1 times 4 is 4, and 2 times 4 is 4. And over here, 2 times 6 is 12, and 4 times 3 is 12. And then
That has to be true.
Yeah.
What you're now, that's not actually the relationship I was looking for you to see. You found a further, deeper relationship than what I was even shooting for. Snaps, right? We're too cool to clap. And there's no doors. Snap. Then,
Well, x, if you multiply x by 10, you get y.
y is just double the x. So when you can say direct relationship, double my x, get my y. Does that work over here? Sure, double. Ah, crap. Worse and not even close. So it works over there, starts to work here, falls apart. Right? So this, add one, add one, add. If I add one, I get my y, add one, get my y, add one, get my y. This equation would be my y is always the x plus 1, which this part right here is what makes it not proportional. It's still linear. That's the y-intercept. That's deeper than we care about right now, but that's the y-intercept. It's the start point, the y-intercept. Just all time left. Wonderful. Okay, by the way, to not move on because what Naya found was pretty awesome. You are comparing my first x to my second x is going to be proportional to my first y and my second y, which cross multiplication rules tell me this has to equal that. That's what you discovered, was the proportion of x to x, y to y. We can also set that up x compared to its y, 1 to 2, and x compared to its y. Isn't that kind of cool? So whether we compare x to x or x to y, we actually get the same thing. Izzy?
I noticed something too.
Okay.
If you look at it, the numbers are next to each other. If you put the x on top of it, it equals a half. For all
Yep,
of them.
they're always half. So we normally do y on top of x, and that's how we got 2. That's why we put y is 2x. All right, let's see if we have something else that we should do. We have a lot of something else's that we should do. This is going to be fast. 38
That is not
is A proportional.
never.
Why?
Definitely.
Because it's
Does it hit either of the boxes?
No.
Does not check either box. B,
No.
is it proportional?
No.
What is it?
Linear.
It's linear. C,
Linear.
it's linear, not proportional. And D, ooh. So we don't actually know. This might be quadratic. It might be exponential. We would need to see. Can't tell right now. And so you don't need to understand any of those words. I just like to throw things at you so they're in your brain. So when you hear them again, you're like, oh yeah. So quadratic, exponential. So 39. We need to go back to our resource page. Hopefully you still have that out or pull that back out. We want to solve for some weights that did not exist. And this actually was not on the graph. So 7.5 pounds of motts. Well, we found out that the cost of the motts cost is what? $3 times the pounds of motts, right? So 3 times how much M you have. So to solve for 7.5 pounds, we know the unit rate, right, are $3 per pound. What would 7 pounds cost? 21. That's another half a pound. Half of the unit price. So we'll end up with 22.50. Try BCD. Try BCD. We got 3 minutes. Try BCD. Most of my money is now locked up. I took the cash out of my wallet. I don't carry lots of cash with me. I normally have at least one larger bill for the just in case, so always it's a good idea to keep a large bill on, like a 20 or something, and then whatever small bills. No, because you wouldn't be able to use it. You don't know anything. For my cards. Credit card. You got my insurance card. What was the cost of Havarti per pound?
It was
$2.50 per pound of Havarti. So if we plug in 1.5 pounds of Havarti, 375. So of course we would be plugging in to this H or that M. Now wait a minute. C is confusing. Zen, how do we look at C?
Well, because it says how much mozzarella cheese can Casey buy with $12. That's basically like what we had earlier with the pennies. How one side was blank, and the other was filled in. If you take the unit rate, or just look at your graph, it should be filled in already. But take your unit rate, which is $3, and then multiply by 4 to get 12. Then you know 1 multiplied by 4.
I love it. Now the other way we can do this when it doesn't work out as well, do we know the cost or the amount of cheese? We know the cost. So what Zin did in his head, he said, well, 12 equals 3 times something. How much mozz must there be to make this happen? 4. And if Casey's got $10, how much Havarti? Anybody? Again, 4 pounds. So Havarti's slightly cheaper, but mozz is probably slightly better. Yeah, we talked enough about this thing. Hold up. Give me your attention while you start packing up. In Schoology, and during my plan period, I'm going to get more of this put up. In Schoology, I've now started posting our answers. So, we are going to probably split classes. Like, in Schoology, I don't want to, but it's probably just going to be easiest. So, this is for Math 7, but I'll post the same thing for you guys, but it'll say Accelerated 7. When there are these pictures here, it's screenshots from my teacher edition textbook, because that's going to save me a lot of time. Work smarter, not harder. I'm not going to type up the answers, and I can just take screenshots. So, hey, I didn't tell you to leave, and it's not time to leave. So please stop trying. When you click this, it'll pull up the picture of my textbook. What is in bold? That's the answer. So you would have a diet, and this is not your homework. But the answer for this homework says C diagram. You need to have a diagram. And you would also be figuring out the answer of 21. This one had, like, see how many times you can do it. So it gives a few examples. Do not look at the answer key as the end-all, be-all. That's absolutely what I have to have. It is a guide. Your answer, you might have taken a different route to get to Florida. Right? So if you're confused on anything, that's when you come ask questions. Tomorrow we're going to go over your guys' masteries. Have a wonderful day. From Unit 2, the chapters 2 and 3.